Alright guys, in this video we're going to go over some angle pair relationships. We went over these in class on Monday, so this video is just to kind of catch you up if you missed Monday's class or you just wanted to see some more examples. Alright, so in this first picture I have two lines that are intersecting. So when you have two lines intersecting, there's two special pairs of angles. If they are on opposite sides, those are called vertical angles. And vertical angles are equal to each other. So angle 4 would equal angle 2. The other pair of vertical angles on here are 1 and 3. So angle 1 would equal angle 3. The two that are side by side, if you look at how I drew the arcs for 1 and 4, you can probably see that if I connect those two, it makes a semicircle. A semicircle is 180 degrees. So because they are on the same line, we call those a linear pair. And linear pair are supplementary. Which means they add up to 180 degrees. So 1 and 4 equals 180. And I mean, there's a lot of linear pairs here. So like 1 and 2 are a linear pair. 2 and 3 are a linear pair. 3 and 4. Basically, any of them that are next to each other, they're going to be on that same line. So they're going to add up to 180. All right, when you have two parallel lines cut by a transversal, there's even more angles that show up. Yes, this picture also has vertical angles. Yes, this picture also has linear pair angles. But 3 and 5 are a pair of alternate interior. So that means they're equal to each other. 2 and 8 are the other pair of alternate interior angles. So angle 3 and 5 are the same. Angle 2 and angle 8 are the same because they are alternate interior. Alternate because they're on different sides, and interior because they're inside the parallel lines. All right, other pairs of angles that are equal to each other in this picture are corresponding. Corresponding angles are in the same position. So angle 1 and angle 5 are corresponding because they're both in the top right of their group. See how 1 is in the top right of that group and 5 is in the top right of that group. So corresponding angles are equal to each other. So angle 1 is equal to 5. 2 and 6 are corresponding. 4 and 8, because 4 is the top left, 8 is the top left. And 3 and 7. So those pairs are equal to each other. The last one that we really use is consecutive angles. Consecutive angles are, if you remember with the parallelograms, like if I connect this side, see how that makes the shape of the parallelogram? Consecutive angles are on the same side. So it's only 2 and 5 and 3 and 8. Because I could draw like another little parallelogram on this side. So those are corresponding, consecutive. And consecutive angles are also supplementary. So 2 plus 5, angle 2 plus angle 5, and angle 3 plus angle 8 is equal to 180. All right, the last picture I can tell involves a 90-degree angle because of this box. So whenever you have two angles that are getting put together to make 90 degrees, those are, I'm not going to be able to put it, complementary. And so I know angle 1 plus angle 2 would add up to 90 degrees. All right, so all of those properties are going to help us figure out how to set up the equation when I am missing an angle or if I have to solve for x. All right, the two angles that we learned about that are in circles are central and inscribed. So this angle would be central because it goes to the center of the circle. This angle here is inscribed because all 3 points are on the circle. So you do need to be able to tell the difference between which one is central and which one is inscribed because their properties are different. So if you look at the way I colored in this angle, the arc that is being like cut by this angle is arc AB. So AOB is the angle, AB is the arc. And there's a relationship between those two. So in a central angle scenario, the angle equals the measure of the arc. So if this was 50 degrees here, then this arc is also 50 degrees. All right, with inscribed, again, the angle is angle AOB, but this is the arc that's being cut, arc AB. So the relationship is a little bit different with inscribed. The arc is equal to 2 times the angle. Another way to look at that is if you have the arc, you can cut the arc in half, and that will equal the angle. But basically, the arc should always be 2 times bigger. So if I use that same 50-degree angle, now that this is an inscribed angle, it would make this arc 100 degrees because I have to double the angle. The arc should be 2 times bigger than the angle. All right, so we're going to use those properties to help us set up equations to solve for x. So my first thought is, what kind of an angle is it? My second thought is, how do I set up the equation? So because this is central, I know that the angle and the arc are equal to each other. So 2x plus 10 equals 60. And I'm just going to solve that equation for x. So I would minus 10 on both sides, divide by 2. X is 25. So if I plug 25 back in, I should get 60 because those are supposed to be equal. In the second example, these are inscribed. So I know that in this case, 2x plus 10 does not equal 60. I either need to cut the arc in half or I need to double the angle. Whichever one, it doesn't matter. So both of these are going to come out to be the same. So either we need to double the angle or we need to split the arc in half. Those are your two choices. So I would distribute minus 20, divide, and I get 10. And it's the same thing over here. If I minus 10 on both sides and then divide, I still wind up with the same answer. But you either need to double the angle, make the angle 2 times bigger, or split the arc in half, divide the arc in half. Keep in mind that those vertical angles might come up in these pictures. You still might have linear pairs. A semicircle is 180 degrees. Another thing that might come up is if these two chords are the same length, then that means these two angles, I'm just going to put a Y there for now. Sorry, these two arcs are the same. So remember, there's 360 degrees in a circle. So if from here to here was 60, then that means the rest of the circle is 300. And if I knew that those were equal to each other, I would split 300 in half. So a lot of these problems are going to require multiple concepts and multiple definitions. So it will be really helpful if you remember the angle relationships from up here. And you obviously need to remember the relationship between the arc and the angle.